Assalamualaikum warahmatullahi wabarakatuh, and a very good day to all the students. So we are in subject DRM1413 Manufacturing Technology Section 1. So today we are going to continue our topic, which is still in Chapter 4 for metal forming. So actually by today we are going to look at on several processes under sheet metal working. And previously, if you notice from this illustration over here, previously you have learned the metal deformation for a bulk metal. And from today, we are going to look at on the sheet metal working under metal forming. And today we are going to look at on several processes for sheet metal working, like cutting, bending, drawing, and also other types of sheet metal working operations. As an introduction for sheet metal working, um, sheet metal can be cut and forming um, using various processes as mentioned just now, like through cutting, bending, drawing, and EDM, electric wire cut drawing, and so on and so forth. Yeah. So why they call it as a sheet metal working? Because this one it use sheet metal as the raw as its material to produce a final product. Well, previously we been using a bulk method to deform it, to form it into our own desired shape. And products that include sheet metal parts like automobile and truck bodies, airplanes, railway cars, farm and construction equipment, and so on and so forth. Sheet metals need to have certain characteristics like high strength, good dimensional accuracy, good surface finish, low cost, and so on. And this process normally being conducted at room temperature. Um, However, there's also hot process for sheet metal working, and this one is normally being used for thick metal, brittle metal, or it requires significant deformation. And equipment used for sheet metal working is called stamping press, and the tool is called as punch and die or stamping die, and sheet metal products are called stampings. So for today, we're going to look at on three main sheet metal working formation, which is cutting, bending, and drawing. After that, we're going to look at on the defects as well as other types of processes for sheet metal working operations. Cutting is a normal process whereby you need to have a sheet metal over here, and then this is the sheet metal, and then the die. This is die, and puncher. Puncher is the cutter. So um um you just cut. I mean, normal cutting like you're cutting cake or cutting papers, cutting the wood. Okay, so the process is the same. Okay, for sheet metal. Um, in cutting operations, these are the things that you are going to look at, that you are going to see through. I mean, after cutting. Number one is rollover. Rollover means it is where the plastic deformation occur. The first point that we cut, the sheet metal being cut. Number two is region called as burnishing. Burnish. This one burnish. It is a relatively smooth region that results from penetration of the punch into the work, puncher or cutter. Under burnish, the third part is under burnish or fracture zone over here. This one is a relatively rough surface due to fracture metal. And then at the bottom part is burring or burr over here, a sharp corner caused by the elongation of metal during furnace separation. So in cutting can be divided into three categories. it can be conducted through shearing, it can be conducted through blanking, and it can be conducted through punching. So let's look at one by one. As for shearing, in our previous lecture, I did mention that the cutter itself need to have an angle in order to cut. It's like a knife. So a knife, it cannot be rectangular. It need to have a certain angle so that the specimen can be easily cut. It's like a knife, yeah. Um, and then number two is blanking. If you refer to figure A over here, so actually, imagine you have a blanking, huge blank, then you start cutting. You want to produce a final product with a rectangular blank. So you cut it using a puncher with a rectangular shape. Then you blank it. After that, producing a rectangular blank. This one. This is the final part. Okay. And the rest of other parts is actually a scrap. Things that we don't want. Number three is punching. Punching actually creating a hole on our blank. So the process is more or less the same as blanking, but for punching, um, the scrap is the one that being removed from the blank as compared to blanking. Blanking, this one is a part, the final part that we want, and the rest is scrap. For punching, again, this is the part that we want, and this one things that being removed from it is called as scrap. Other cutting operations include like cut off. Cut off is a process whereby blanks are separated from sheet metal strip by cutting the opposite sides of the part in sequence. So figure number A over here, yeah. The cutting edges are not necessarily straight. The blanks can be arranged on the strip so that no scrap is produced. And number two is parting. Parting means punch with two cutting edges that match the opposite sides of the blank. Normally, this one is used to produce a regular shape and less efficient since waste materials are produced. The waste materials are higher as compared to other types of cutting operations. And then slotting, this one called slotting. Punch operation that cuts out an elongated or rectangular hole. Next is perforating. This one, figure B here, is a process of simultaneous punching of a pattern of holes in sheet metal. The whole pattern is normally for decorative purposes or to allow passage of light, gas, or fluid. And last but not least, for cutting operations is notching or semi-notching. Notching is a cutting out a portion of metal from side. This one, figure C. Semi-notching removes a portion of metal from interior of the sheet. This one is semi-notching. Um, okay, there's other cutting operations included here, like shaving. Shaving is like you shaving your beard and so on. So it is actually removing a very small clearance just to obtain accurate dimension and smooth straight cut edges. Typically, this one is used for finishing operation only. And then fine blanking. This one is used to obtain close tolerance and smooth straight edges in one step. And the punch descends with slower than normal velocity and smaller clearances, usually for relatively small stock thickness. Small stock thickness means a blank with a lower thickness value. In cutting, we do need to conduct analysis as well. So in cutting, the formula for you need to know the clearance. Clearance formula for clearance, C equals to A C T. AC represents the clearance allowance, and T stock thickness. This is stock thickness T. Clearance allowance is determined according to the type of metal. So different types of metals have different value of allowances. So basically, you need to be aware of what types of materials or the blank is being made of. From there, the clearance allowance is actually difference between one and another. So what happens if clearance is too small or if it is too large? If it is too small, the fracture lines tend to pass each other, causing a double burnishing and larger cutting force, as you can see from this figure over here. This is fracture line, so it will create double burnishing and large cutting forces. Which finally, this one will create a damage to our final product. And if it is too large, the metal becomes pinched, like this one, pinched between the cutting edges and results in excessive burr. So this one is burring. So, okay, burring. And another part is that the die itself need to have a clearance between 0.25 to 1.5 degree, so that um, it is easy for our blank to drop through and it won't stuck between the die. Other than that, a punch and die size. Okay, this one you need to know the terminology for punch and die, like what is blanking punch diameter, how to find it, dB. Okay, dB die size minus 2c. C over here, C is clearance, two sides of clearance. Blanking die diameter, dB. So this is a dB, blanking die diameter. Okay, other than that, hole punch diameter, DH, hole diameter, DH plus clearance, two sides of clearance. And cutting force, we need to know the formula for cutting force, which is F equal to STL. S is shear strength of the metal, T stock thickness, or blank thickness. L is length of the cut edge. Okay, and if there's no shear strength being mentioned, then the value the cutting force can be calculated using this formula. F equals to 0.7 TS TL. TS is ultimate tensile strength, or sometimes they use as UTS, so it is the same. Move on to second types of sheet metal working, which is bending. Bending means you have a sheet metal, then you start form it by bending it a little bit, or to certain degree of bending angle. And two common bending methods are normally being conducted, like a V bending and edge bending. So you can look at the terminology, the symbols over here. This is the bending axis, bending angle, bending radius, stock thickness. Okay. V bending, metal is bent between V-shaped punch die, like the one that you can see from this figure A. Okay. The die is called V die. Okay, this one die, and generally used for low production operations. V dies are relatively simple and inexpensive, so very cheap. For this one, the process is very cheap. Meanwhile, for edge bending, the die is called as wiping die because if you notice the stock over here or sheet metal over here, it is being deformed at the edge, or the process is like whipping. Okay, whipping. Edge bending is limited to bend of 90 degree or less. And in bending also need to have a bend allowance with the symbol of AB. And this is the formula. Alpha represent for bending angle. This one alpha. R is bend radius, radius there. T is stock thickness. KBA is factor to estimate scratching. So for KBA, we there's two value over here, which is 0.23 and 0.5. This one, for example, we can use KBA equals to 0.3 if the value of band radius lesser than 2t, 2 times t. T is stock thickness. And if R value, band radius is larger or equals than 2t, then you need to use KBA equals to 0.5. Or afterwards, we're going to do the example together, yeah, to make you understand better on how to use the formula. Other than that, spring back. Some metals, they once we deform it, they want to change to its original shape. So this is called as spring back. And the formula for spring back is as P equals to alpha prime minus alpha T prime divided by alpha T prime. And alpha prime represent the angle of sheet metal part, and alpha T represent angle of the bending tool. So how can we deform? How can we overcome this spring back? So in this case, we need to do overbending or bottoming. Overbending means that we need to punch angle and radius. The punch angle and radius are fabricated slightly smaller so that the part springs back to the desired value. Meanwhile, for bottoming, the process includes squeezing the part at the end of the stroke, those plastically deforming um, in the bend region. So finally, it will form the V shape following the shape of the die. And this is the formula for bending force. F equals to KBF ds WT square divided by D. And you may look at the terminology over here for each symbols there. Okay, now let's look at example for analysis for bending, on how to do analysis for bending. Question asks you let's read the question together. A sheet metal blank is to be bent as shown in figure. So this is the part original part and view, side view and view. Okay. To be bent like this, the metal has a modulus of elasticity equals to 205 times 10 power of 3 MPa, yield strength 275 MPa, and tensile strength 450 MPa. So find the starting blank size. A starting blank size means the length from this point until this point, which means before it is being bended. So how can we find this how can we solve this problem is actually by using this one, because we know the length for 38, then we know this side of the length, which is 25, but we don't know this bended length. So the bended length using this formula. So just substitute all the information given into the formula, then you should be able to get the value of 6.08 mm. Okay. um So the total length is actually summation of 38 plus 6.08 plus 25. So altogether, the total length of the blank is equals to 69.08 mm. Number two, the bending force if a V die is used with a die opening dimension equals to 25 mm. So using this formula, okay, then just substitute into the formula using the information given, then you should be able to get the value of 10.909 kilonewton. Okay, so please be aware the usage of KBA and KBF in this formula. So number three is sheet metal other types. Number three for sheet metal working is drawing. Drawing, let's look at the illustration over here. So you have a blanking, then this is the punching, this one is die. So you start giving a force to the blank and finally forming a desired shape following the shape of the die. So basically drawing is used to produce a cup or box or other types of hollow shape products. And these are the terminology or symbols used in drawing, like DP, blank diameter, punch diameter, corner radius, punch radius, the clearance. If you notice here, clearance, the side of the die and punch are separated by a clearance C. If you notice C over here, and of course this side as well, C, with the value of about 10% greater than the sheet thickness, C equals to 1.1 T. Because you see, once the sheet metal being pressed, being punched or being drawn, it will create stress in the sheet metal. Stress and heated be introduced to it, then the thickness will increase a little bit, um, which means that the thickness will get increasing as compared to its original thickness. And that's why we need to have a clearance there, otherwise it will stick to our die. So these are the steps in conducting drawing. First of all, of course, you need to have a sheet metal blank, or stock over here. After that, this one the puncher. So you start pressing, you start giving force to the punch, and the material start to bend. And then giving more force to it, so the metal start pulling down, and it will start following the shape of the die. This one called as strengthening over here. And at this point, friction and compression is very important, because at this point, at this area, we need to reduce the friction over there. Otherwise, it is very difficult to form the sheet metal, and it will require high value of forces for puncher to shape that stock. So in step 4, as metal in the flange moves toward the center, it is subjected to the following state of stress. So, as mentioned just now, once once the stock being pushed by the puncher, then it will suffer stress in it, and of course the heat will introduce to it, which at the same time it will increase the thickness will increase a little bit. And that's why we need to have a clearance with about 10% over here, so that it can fulfill, it can nicely fit, nicely fit the shape of the die. So basically, in order for the material to be drawn, friction between sheet metal and surfaces of the blank holder and die must be overcome, which is over here. Number 2, deformation energy should be provided. Otherwise, it is very difficult for us to deform these types of stock or sheet metal. So deformation energy being provided to the punch. The downward motion of the punch results in continuation of metal flow caused by drawing and compression. Some thinning at the cylinder walls occur as well. Okay, thinning at the wall, this point. Set 5 shows the complete drawing process. So basically, this is the final part, final product of a drawing process. Um, This figure here actually shows you on how to produce aluminium can. because some people, they think that to produce aluminum can, we can just use one step of drawing, then that's it, the can itself is final just by using a single process. Well, it is actually no. To produce an aluminum can, well, at least this one requires several steps, more than 3 steps to produce its desired shape. Okay, it start with deep drawing. So once this drawing, so this is how how it's seen as a final, as a first stage. Okay, this is how it can be seen. This one, this side is actually the cross section, and this one is for 3D illustration, 2D illustration. After that, after deep drawing, it goes to redrawing. It redraw again, so the shape will be slightly smaller. The diameter becomes slightly smaller, and the depth getting increasing. And then ironing, which means that using the redrawn carb, okay, then start iron again. It will become thinner. It become thinner and longer. After that, doming to produce this shape. Okay, so you'll see the illustration over here. After that, necking, neck over there. Okay, for to close the thing. And then seaming the other part there. Okay, so that is the complete process to produce aluminum can. Same goes to other types of aluminum can, bottles. So bottles which made from metal. Defects, yes, of course. Any types of process, they are subjected to several types of defects. So same goes to drawing. Defects that can be found in drawing, like wrinkling in the flange, wrinkling. So like this, it caused by compressive buckling. Number 2, wrinkling in the wall. This one wall. It happens when the wrinkle flange is drawn into the cup. It will appear in the vertical wall. Okay, and then tearing. This one, tearing. It is an open crack in vertical wall, usually near the base of the drawn cup, caused by high tensile stresses that cause thinning and failure of the metal at this location. Also caused by sharp die corner. That's why normally we don't use sharp corner, but we need to use fillet instead. Yeah. Number 3 is earring. This one, earring. Irregularities at the upper edge caused by anisotrophic in sheet metal. And E is surface scratches. This one happens due to the punch and die that are not smooth or insufficient lubricant. Other types of forming processes for sheet metal is explosive forming. Well, I'll show you video for explosive forming. How can I? Sorry.
Explosive forming is a metalworking process that uses energy from an explosive to form a metal into the shape of a mold. The sheet is placed on top of the mold and the air beneath the sheet is evacuated. This is done to prevent the air from stopping the metal sheet from being pressed into the mold once the explosive is triggered. Next, the tank is filled with water to maximize the effect of the shock and pressure wave. Finally, an explosive is placed above the metal. When the explosive is triggered, it creates a shock and pressure wave. When the pressure wave hits the metal sheet, it then forces it into the shape of the mold. Explosive form.
Okay, so it's a very easy process for explosive forming. And other than that, there's also known as electrohydraulic forming. Well, the process is actually more or less the same as in explosive forming, and it uses high energy rate forming. And this one also called as EDF, electric discharge forming. And as compared to explosive forming, this process, electrohydraulic forming, the process is used to deform, to form a parts, a smaller parts. Okay. However, these two types of processes actually is very, I mean, it's quite expensive as compared to a process like bending, drawing, and cutting, because this one use high energy to form the sheet metal or stock. Other than that, there's other process called electromagnetic forming. Well, this one use electromagnetic current, yeah, electromagnetic to deform the metal. And in drawing, things that you need to know for the analysis is drawing ratio, dr, and then reduction, and also thickness to diameter ratio. So these are the formula that you need to remember on doing the analysis for drawing process. I think let's do this example together. Okay, the question, let's read the question together. A drawing operation is used to form a cylindrical cup with inside diameter equals to 75 mm and height equals to 50 mm. The starting blank size equals to 138 mm and the stock thickness equals to 2.4 mm. Based on this data, is the operation possible? So these are the formula that can be used to solve this problem. Okay, first of all, things that we need to find is the dr. So just use the information given to find the value of er, which is equals to 1.84, and then the radius, substitute the information, then you should be able to get the reduction equals to 45, not radius reduction, sorry, yeah, 45.65% reduction. And then thickness to diameter ratio is equals to 1.7%. So based on this data, is it the operation is possible to be conducted? I think for this one, you may answer it we you may answer it in our class in the next class. So please be ready with this question. So based on this data, whether the operation is possible or not. So please be prepared with your answer, and we'll see in the next class. And other than that, maximum drawing force. This is the formula for drawing force. And you may look at the terminology for symbols over here. And then the holding force, yeah, holding force at this side, holding force. Because as mentioned to you earlier, the friction over there should be reduced. Otherwise, higher energy or higher forces is required to deform the stock. Okay, again, example for a drawing. Let's read the question together. A drawing operation is used to form a cylindrical cup with inside diameter equals to 75 mm and height equals to 50 mm. The starting blank size equals to 138 mm and the stock thickness equals to 2.4 mm. Determine the drawing force and holding force or blank holder force. Given tensile strength for sheet metal made of low carbon steel equals to 300 MPa and yield strength equals to 175 MPa, corner radius equals to 6 mm. So use this formula for drawing force, this one for drawing force, and this one for holding force. I think all the information is given to you, so you just substitute into the formula. You should be able to get the value for maximum force equals to 193.396 kilonewton, whereas for holding force you should be able to get 86.829 kilonewton. As for the extra exercises for you for these topics, please answer this question, and you don't have to submit now, but you have to compile all the exercises from different chapters, from different subtopics and chapters, and then please submit it at the end of this semester. With that, thank you very much for your kind attention and cooperation. Hopefully, you understand what are being taught to you about these topics. And still, if you do have any question related to the topic, you can always reach me through WhatsApp group or Kalam. So that's it for today. See you on the next class. Don't forget the exercise just now. Please answer it and we'll discuss in the next class. So with that, thank you very much and have a nice day. Bye.